Here we have basis for the Lie algebra SO3. And here you see the commutation relations. So now the bracket here is the matrix commutator, and I times that would be the Lie bracket. And we want to study the exponentiation of a Lie algebra element. So psi is a real parameter, n is a point on the sphere, a direction, which we want to write as a 3 vector. So this means that n times j is just a linear combination of the generators. So this is a Lie algebra element here. And now the claim was that this exponential here is really just a rotation about axis n by angle psi. How can we see this? Well, let's take this Rn of psi and apply it to some vector. Let's call it x0, and let's call the result x of psi. Then if we take the derivative of this, let's say dx d psi at psi, what happens? This is an exponential, so we just get this minus I times nj here. And then the rest reproduces. So we have minus I nj, and then we get again x of psi. So this x of psi solves a simple differential equation, an ODE, and actually it solves an initial value problem because x of psi equals 0 is this x0 here. Okay, what's this matrix here? Minus I times n times j. Well, minus I times j1 give us 1 down here and a minus 1 up here, and we have to multiply that with n1. So we have 0, n1, this will not remain 0, n1 here and the minus n1 here. What do we get from the n2 times j2 term? We get a minus sign here and a plus sign here, and all this with n2. So we have minus n2 and n2 here. And from the n3 times j3 term, we get here in this position a plus n3, and here we get a minus n3. And we have zeros on the diagonal. So this is this matrix here. Now if we take this matrix and multiply it with some vector x, let's multiply it with some x, and let's write this x as x1, x2, x3. Then what do we get? So here this is minus n3 times x2 plus n2 times x3. Here we have n3 times x1 minus n1 x3, and here we have minus n2 x1 plus n1 x2. And if you look at this, then you see that this is actually the vector cross product n cross x. So we really found that dx d psi at psi is n cross x of psi. What does this mean? Well, if we draw this, then we know that the change in the direction of x when we solve this differential equation here is always orthogonal to n and to x itself. So if we have our axis n here and some x of psi here, now when we propagate this, increase psi, then the change in the direction is goes into the drawing plane here. So it is perpendicular to both n and x, which means that we get this, the arrowhead of the vector here moves on this circle. The whole thing describes a cone. So we really have a rotation about this axis n here by this angle psi.